Today I'd like to talk about a few things. First, by the way, how many of you are developers? Okay, unknown developers? A few, okay. Anyway, so first I'd like to talk a little bit about the sum of programming languages we have, and also we'll go into more details on the monitoring topic and about Zabbix specifically. So, who am I? My name is Alexei Vladishev. I'm creator of Zabbix, and Zabbix is an enterprise-level open-source monitoring solution. I started my work on Zabbix a long time ago, in 1997 or 1998. Currently, I'm a CEO and architect of Zabbix. Basically, I'm responsible for all technical decisions in regards of Zabbix and the Zabbix roadmap. Okay, so we have many programming languages right now, yeah, so some higher level languages, well, Java, I don't know, Python, interpreted languages, lower level languages like C, C++. And let's have a look at a few examples. The C programming language. Actually, this is a language which is used as a foundation of almost everything we use now. It's a language we used for Linux kernel, for GNU utilities, for all very important parts of our application stacks. And it's very low level. If you write a code in a C language, you may feel how it will be mapped to actual CPU instructions. It's very high level. It's very low level. But since it's low level, obviously it has some problems. So we have to take care about memory management. We have to take care about pointers and all these different things. There's another one called Java. Java is a higher level language based on the JVM, so it's a certain level of abstraction. So we don't care much about the memory management. It's all handled by a garbage collector, but still. Java allows us to write kind of higher level code, so business logic could be written in a much faster way. But obviously, since we have a garbage collector, we may have some problems related to, well, out of memory, because it's really hard to figure out how much memory we need for our application. Yeah, sometimes garbage collector works and it affects our application in a certain way. We have other types of languages, say Haskell. I like Haskell very much. Actually, I try to use Haskell with no great success, obviously. But this language is very nice. It's a functional language. It's built to introduce a mathematical, basically scientific approach to the programming. It actually introduced very nice concepts like pure functions, like laziness. So all interesting functional things. But even though in Haskell we may write programs in a highly abstracted way. And looking at the Haskell program, it's really hard to understand what does it mean. What does it mean in terms of performance? What does it mean in terms of instructions which are going to be executed on the CPU side? Because we are writing in a very abstract way. And obviously we may also get certain problems in the runtime when our Haskell application is running in our production environment. And actually, we may see that no technology, no programming language may provide us some guarantees. Guarantees about performance, guarantees about availability, because any program may crash for some reason, for one reason or another. The programs may run slowly, for some reason or another. They may run out of available memory, or they may run out of available, well, file descriptors, whatever, yeah? And it's a pain. It's a pain. So despite of all effort we are doing to make our programs very stable, we're still expecting problems in the production. And actually, today we had a very nice talk from Confluence guys, yeah? And this is what I found in Confluence. Confluence is an enterprise wiki written by Atlassian, from Atlassian. The company name is Atlassian. And actually, the users are asking, so how much memory I need to run your application? How much memory is required to run Confluence? And the response from developers, they know, obviously, the software very well. And they're good developers, yeah, they're very nice developers, good developers, and they basically saying that we don't know. So we don't know how much memory is required to run our application, because it depends. It depends on so many things. It depends on number of users working with Confluent, the use pattern, the different, it may depend on the architecture they're running on, and so on and so forth. So there are so many different factors. So they cannot give you, the developers of these applications, they cannot give you exact answers of how much memory is required to run this application. And actually, it's not something specific to Confluent, not at all, absolutely. If you ask Zabbix how much memory you need or what kind of resources you need to monitor, say, 10,000 or 100,000 of hosts or network devices, the answer will be exactly the same. We don't know. Because it depends on so many factors. It depends on how we are going to monitor these devices, how many checks per second will be executed, what's the backend database, and so on and so forth. So there is no way to come up with a very simple formula. Okay, the amount of memory, this formula, the CPU usage, this formula, network utilization, something else. So it's really, really hard thing. And actually, and because of this, because there are no guarantees by developers, so developers don't really know what might be the resource usage of the application. Programs may crash because of bugs, because of even hardware issues. So on the CPU level, for memory or whatever, there could be some corruption. Actually, anything may happen in the runtime, and that's why we really need a monitoring solution. And monitoring is, as I define it, is about describing something abnormal. Yeah. So something, if our application is running fine, this is normal. It runs 24/7. It's available. It performs very well, handles, I don't know, thousands of transactions per second, no problem. But with monitoring is about catching some problems, catching some issues. Yeah. So actually, any monitoring tool is about describing problems in catching problems and reacting to problems in some human way. So, but the question is how to detect problems. And let's have a look at and if you start using some monitoring tools, a very typical approach is to use some thresholds. Yeah, say we'd like to detect this if our system is overloaded. So we use a simple threshold like CPU load is 5, and if CPU's load is more than 5, we think that okay, the system is overloaded. Okay, the problem will be here, recovery here, obviously, another problem, recovery problem, and so on and so forth. So we hit threshold, we've got problem, we go below the threshold, there will be a recovery. Well, it's a very naive approach. Yeah, it's very, well, it's typical, but it's kind of a very simple and oversimplified approach. First of all, it's too sensitive. We have this situation, we've got problem recovery, problem recovery, problem recovery, it's so-called flapping. And if our monitoring system starts to generate so many messages to users, so many alerts, it means, okay, we cannot trust the system. Do we want to be woken up at 2 a.m. just to know that system is overloaded? And then again, at some point we'll just start ignoring these messages and saying we'll send all of them to dev now, and that's it. Yeah. So the trust is really, really important. Zabbix does it in a little bit different way. Once again, Zabbix is a monitoring tool, open source, free monitoring system. We don't have any closed source or enterprise versions of Zabbix, so everything we do is absolutely free. So you may go to zabbix.com, download Zabbix, and use it for free, absolutely, even if you have a very large enterprise environment. So how does Zabbix works? It collects data. It does data collection from different resources, log files, some metrics, performance metrics like CPU utilization, network utilization, memory, and so on and so forth. It operates on a different level, from hardware level to software and business level. Then it stores all information in the database where we keep all the history. And then Zabbix basically analyzes this data. So Zabbix server is analyzing data, real-time information. Maybe it may perform 100,000, 10,000 of checks per second. Then it tries to find problems in this flow of data. And if problem is detected, it reacts somehow. Maybe Zabbix may send alert message to user, or it may try to fix problem in automated way. So we see that Apache is dead. Okay, Zabbix will try to restart Apache automatically. Nginx is dead. Okay, we are trying to restart Nginx or Windows service, whatever. Now, since we have a history, we may take advantage of the history analysis. So what we basically do, we define a little bit different condition. If CPU load for the last 10 minutes is more than 5, so our decision is not based on a single value, but we take the range of values for the last 10 minutes. If CPU load was more than 5 for the last 10 minutes, we've got a problem. I use a very simple examples. This is very, very simple and trivial example. And in real life, of course, we may have much more sophisticated expressions, these expressions. Okay, so in this case, we don't go into a problem state immediately here. We wait for 10 minutes. Okay, CPU load is more than 10, is more than 5. Okay, the problem is here, and recovery obviously is here. Another thing I'd like to talk about is that the fact that problem disappeared, it doesn't mean that problem is resolved in the proper way. Yeah? We have no problem, it doesn't mean problem disappeared completely. Let me give you a very simple example to illustrate this idea. Say we have a simple condition, free disk space is less than 10%. So we'd like to be notified when our free disk space is less than or equal to 10%. And the question is, if we have 10% plus 1 byte, doesn't mean that the problem disappeared. We no longer have this problem. So, well, I don't think so. The problem is, in fact, it is resolved. Yeah, it is resolved, but it may appear anytime soon, because the difference between a problem state and a kind of okay state is just a 1 byte. So we are very in an unstable position right now. So in Zabbix, we may take advantage of using different conditions for problem and recovery states. So we go into problem state when CPU load is more than 5, but we'd like to recover only when CPU load drops below 1. Okay, 5, there is a problem. Okay, problem, and then recovery when CPU load drops below 1. Because when CPU load drops below 1, we know, okay, finally there are no kind of processes which taking all CPUs, so CPU now is more or less free. So no flapping. No flapping, and why is no flapping? Because this distance between the problem and recovery is not just 1 byte, or is not just 1 second. We cannot jump immediately from problem to recovery, yeah? It should take some time. So there is a distance between the problem and recovery, so we have no flapping now. And the smarter approach would be to combine different conditions for problem recovery states with the analysis of historical data. So we may do conditions like this. If free disk space is less than 10%, there is a problem. But we would like to recover only if we have more than 30% of free disk space for the last 15 minutes. And only in this case, we are absolutely confident that someone, a sysadmin or DevOps guys, they went to our server, they removed some huge files or maybe extended the file system, and now we may go and sleep well, yeah, because we're absolutely sure that this problem is resolved. Or maybe 3 consecutive checks failed of HTTP REST service. Okay, something is wrong, we go into problem state. But then if 10 consecutive REST checks said everything is fine, they were successful, only in this case we recover, because we know that now system is, we think that it is in a stable state. It also provides anomaly detection. Anomaly detection is about is about comparing the current system state with what we had in the past. So, say today we have twice higher average CPU load than it was exactly 1 week ago. Yeah? So if today, say Friday, so if last Friday there was a CPU load, I don't know, twice less than today, okay, something is wrong. We've got some anomaly. We don't know why it's happened, why we are consuming too much, twice more CPU power today, but this is a fact. So we need to look at and we need to find out why it's happened. It may happen because everything is fine and we've got just twice more customers coming to our website, that's fine. Or it may happen because we deployed a new version of our, well, microservices, and then we've got some regressions. And by the way, I like microservices because it really kind of job security for monitoring systems, yeah, because with the microservices we need to monitor so many things, yeah. So it's a really good thing, yeah, a really good direction for IT industry. But anyway, this is about anomaly detection. So it's not necessarily about the CPU, but it could be about the network utilization, well, kind of, well, transaction metrics like number of transactions per second or number of bills paid, yeah. And if we see today that, okay, number of bills paid twice less or 3 times less than it was exactly 1 week ago, then, or a day ago, then we may have a problem. So it's just a hint to our operations to have a look. So Zabbix will send a message like, hey guys, please have a look. Something is probably wrong. It's not necessarily a real problem, but something may be wrong. And also Zabbix delivers another nice feature, and it's coming in Zabbix 3.0, which we are currently working on. It's so-called forecasting. So Zabbix will be trying to forecast the future. Yeah. So Zabbix will try to answer to 2 questions. The one is when we hit a certain threshold, when we'll be running out of free disk space. So this point in the future, maybe after, well, in this case it's just after 2 hours, but maybe in a better approach would be maybe to detect this after 1 week or 2 weeks. And the value after a period of time. So if you'd like to know how much disk space we are going to have after 1 week or 2 weeks, so what we do, we create a condition, and if we have less than 10% of free disk space, for example, after 2 weeks, the guys will be notified and will have enough time to order maybe new storage or solve our storage problems. Well, and a quick conclusion, a quick summary. Once again, since everything may go wrong in production, hardware issues, software issues, bugs in our software, out of memory problems, we need a monitoring tool. So monitoring gives you some level of confidence that everything is up and running, and if something is not, then Zabbix or other monitoring tool will send you alert, send you a message that, hey guys, please have a look, this service is not up and running right now. And I believe that Zabbix really may be your best friend, especially when it comes to problem detection. And things like anomaly detection, like forecasting, again, it's quite a powerful tool. It's not about detecting the current problems, but it might be a very good approach to detect something that may happen in the future. Yeah? So basically, Zabbix may try to give you DevOps or developers some hints that, okay, the system is not operating as it should be. All right, then, thank you very much, and I'm happy that we are a sponsor of this great conference. We have a booth here, so please come in. If you have any questions about Zabbix, ask your questions at our booth. Thank you.